In this video, the following problem is considered. A dart is thrown horizontally with an initial speed of 15 meters per second toward point P at the board. It hits the board at point Q 0.17 seconds later. Three questions in the problem. First, find the distance between dart and board at the initial moment, dp. Find distance pq, and find the speed of the dart when it hits the board. To solve the problem, we introduce first the reference frame with horizontal x-axis and vertical y-axis, and y-axis passes through the initial location of projectile. X-coordinate of point P, xp, is equal to distance dp, and we need to find xp. First, we recollect that the motion of dart is the motion with constant acceleration g, equal 9.8 meter per second square. Actually, it is a motion of projectile. And to find dp or xp, we will use the well-known equation of kinematics for motion with constant acceleration along x-axis. In our case, ax is 0 because g is normal to x, v0x is v0, and x0 is just 0. So this equation takes more simple form, and we can find xp by plugging in the numbers for v0 and t. And the answer is 2.6 meters. So the distance dp is 2.6 meters. Now we will find the distance pq. To do this, we will use another equation of kinematics which describes vertical motion of projectile. Here y0 is initial position of dart of projectile on the y-axis, y is the position of point q, ay, which is y component of g, is negative g, v0y is just 0 because v0 is perpendicular to y, and the equation becomes more simple. We rewrite this equation in the following form, simple algebra, and we take into account that y0 minus y is exactly pq. The last what we need to do is just plug in here the given numbers, and we have for pq the following answer, 0.14 meters. So the second part is solved. In this third part of the problem, we need to find a speed of the dart when it hits the board. To do this, we decompose first the velocity of the dart in two components, x component and y component. To find x component, we will use equation of kinematics for horizontal motion with constant acceleration. In our case, ax is 0, v0x is constant, v0, and we have vx equal v0, or vx equal 15 meters per second. To find y component, we will use another equation of kinematics. In this equation, ay is negative g, v0y is 0, and vy is negative g times t, or plugging in the numbers, we have the answer, vy equal negative 1.67 meters per second. Now we recollect that v, magnitude of velocity v, is equal square root of vx squared plus vy squared. We plug in numbers which we got previously, and we will obtain the answer 15.1 meters per second. So the problem is solved completely. If you like this video, you may want to hit like button, leave a comment, and subscribe for the channel.